Hi friends, welcome to the Unit 2 Day 7 notes. We're going through example 2, graphing a piecewise defined function. We're going to graph the function by just picking points, stating its domain and range. So I went ahead and copied down each of the parts to a table down here below. This one, when we pick different values, we need to be careful when we pick values inside the domain. I think it's a good idea to pick values that are on the extremes. So, for example, for this one, I'm picking -5 and 1. If I plot this on the graph, know that 1 in this case is going to be an open circle, whatever that ends up being. And then picking a few other points on here. So I'm going to pick -3 and then -1 as well. When I plug that in, -5 plus 1 is -4. Plus 1 is -2, 0, and then 2. So these values, so -5, -4, 1, 2, 3, 4, 5, 1, 2, 3, 4. I know that this is going to be a line, and I know the slope is 1, positive 1. So I'm going all the way until I get to, right, wait a second, something looks off. Oh, there we go. And then here is open. There we go. Remember, that one's the open one. Now it does end here. Notice that it only goes from -5 inclusive, so I need to make sure that I don't extend my line beyond that. So when I connect these points, going just from here to here, again, remember that circle's open. I want to keep it open. And then for this next one, again, I'm going to go ahead and start from kind of the extreme. So here we're going to start at 1. And then just looking at these values, I'm going to think about what can I plug in here that's going to give me kind of a perfect square. So if I plug in 1, that gives me 1 minus 1 is 0, so that's good. If I plug in 2, 2 minus 1, that's also a perfect square. If I plug in 5, 5 minus 1, that's going to be 4, that's also a perfect square. And that's kind of it for this one. That's easily, because if I go to 10, that's off the graph. So I'm just going to keep that last one blank for now. Let's see what happens. 1 minus 0 is 0. Opposite of 0 is 0. 0 plus 2 is 2. So this one goes 1, 2. 2 minus 1 is 1. Opposite 1, -1. -1 plus 2 is 1. 5 minus 1 is 4. Square root of 4 is 2. -2, -2. Okay. So here, so when I plot this one, I actually am going to now fill in this circle because I've basically filled it in because of this. So remember, on this side it's open, this side it's closed. 2, 1 is here. 5, 0, 1, 2, 3, 4, 5. And I know, because this is a square root function, I know the shape of it. I know it opens down because of that negative there, because it's a reflection. So this is going to continue. Now, again, the domain continues on forever, so I know that this continues on forever. So when I connect these, and I continue on forever, I know that that also is going to continue on forever. So I went ahead and drew the line there. The domain of this function. So again, my x values, the domain you get actually just from looking here. So from here, we know that the domain is going to be from -5 inclusive. So -5 inclusive all the way to infinity. Remember, I can continue on because it's greater than 1. X is greater than 1. The range of the function, now this one's a little bit difficult to just kind of gather if we just look at each piece. Kind of have to look at the whole picture to get the range. This is going to continue going down forever. So this is actually going to approach -infinity. So my lowest value, I'm approaching -infinity. But here for my highest value, my largest value for my range, it's going to stop here. And that's 2, and that's 2 inclusive because we made that circle there. So keep that in mind. For this one, graph the function and state its domain and range. Can't remember if I gave you, nope, I did not. So we're going to have to kind of just go through and think about what's going on here for each of these values. Again, making a table is useful if you have nothing to go off of. So if I made a table going off with this one, so x, and then f of x for 0 is less than or equal to x, which is less than or equal to 2. So here are these values. If I plug that in, so I have 0, let's do 1, 2, those are good values. So this one, goes off the graph pretty quickly. So I actually probably want to increase my my values here by 2, go by 2s instead. So I'm going to do 2, 4. So let's put a 4 here, 6, 8, 10, 12, 2, 4, 6, 8, 10, 12. Here, there we go. So I plug in 0. 0 plus 1 is 1. 1 squared is 1. Negative 1. Negative 1 plus 8 is 7. And then 1 plus 1 squared is 2. And then 2 squared, 4, negative 4. And then negative 4 plus 8 is positive 4. And then 2 plus 1 is 3. 3 squared is 9. Negative 9 plus 8 is negative 1. So here I have 0, 7, which is going to be 6, 7, so that's here. 1, 4, so that's going to be here. 2, negative 1, 2, negative 1, which is here. That's going to go here to here. Notice that these are all inclusive at both ends. So I made this include at both ends. Now this one, looking back, I could actually have plotted this without changing the scale. 0, 7, 1, 2, 3, 4, 5, 6, 7. Yeah, that would have fit. Sometimes it's helpful to look at it ahead of time. I did not. I just jumped in, forgetting that I actually changed this so that it did work on this. But it's good to know. And then it says f of x equals negative 1 when x is greater than or equal to 2. And if I think about it, negative 1, that's just going to be a horizontal line here. Now I filled in the dot because of this value here. They aren't always filled in. Both of these examples gave it where they were filled in. They aren't always filled in. Sometimes when you connect them, they don't actually quite meet up. And one's just a little bit above or below the other one. As long as you don't have two values of y where you have a singular x, then you're good. Next video, we are going to be talking about graphing a discontinuous. So these were continuous, they connected. Next videos we'll talk about discontinuous. Have a great day.